What makes a fluid flow?
As in all of physics, objects move as a result of a net force. In a fluid, the net force comes about because there is a difference in pressure between 2 points. The fluid flows in the direction of decreasing pressure.
What is fluid statics?
Study of fluids in a state of rest.
Does this look like the original analog signal?
No way. Note that there are 2 problems. First, the wiggles in the wave are missing. Second, with only 8 choices of voltages, the vertical resolution is too small. To make a more accurate conversion, you need to sample the wave more often. At least every 0.1 millisecond, and to allow more than 8 voltage choices, 32 or more would be better. To obtain the quality of sound in a CD, the sampling interval is 22 ℏs. 22 microseconds, and there are at least 4096 voltage choices.
How can that be?
Even though the nails have very tiny tips and would certainly penetrate the skin if there were only one. Because there are dozens of nails in the bed. The person's weight is distributed over many nails, and the force of each nail is quite small. The pressure is not enough to penetrate the skin. Anyone doing this demonstration has to take precautions. The parts of the body not on the lower bed have to be supported at the height of the nails. If the concrete block is broken, the person must wear safety goggles. And a sheet of wood should be held to keep any concrete from flying into the person's face.
What is an inelastic confinement?
In a collision, the kinetic energy of colliding objects is smaller after the collision than before it.
What is an image?
Suppose light falls on your face. Light is reflected diffusely from this surface. That is, it is reflected into a wide variety of directions. Consider a very tiny object, like the end of an eyelash. Light from that point will leave in many directions. That point is called an object. An optical device can cause the light rays from the object to converge again to a single point. That point is called the image.
What is work?
Energy transfer by mechanical means.
What is an ultrasound?
A method of looking inside a person's body to examine tissue and liquid-based organs and systems without physically entering the body.
What is architectural acoustics?
Theaters, concert halls, churches, classrooms, and soundproof rooms have to be designed and constructed so that their acoustic properties match their uses. In some spaces it is important that the speaker, singer, or musician or group be heard clearly in all parts of the room. A good concert hall has intimacy. Music should sound as if it were being played in a small hall. It should have liveness and warmth, fullness of bass tones. The sound should be clear, and the audience should be able to locate the source of the sound. The sound should be uniform over the entire hall. And sounds from the stage should be blended by the time they are heard by the audience. Finally, the hall should be free of noise, from air handling systems as well as outside sounds. In order to achieve these goals, an acoustical engineer must consider not only the size and shape of the hall, but also the acoustic properties of materials used on the floors, ceilings, and walls of the room, as well as chairs and other objects in the room. Even the audience and air humidity affect the acoustic properties of the room. In general, hard surfaces such as concrete, plaster, wood, and tile reflect sound, while soft materials like carpet, heavy drapes, and plush upholstered chairs absorb sound. Room shapes and sizes that create standing waves should be avoided because sound at frequencies at which the standing waves occur will not be uniform. They will be loud in some places, soft in others.
What do Celsius temperatures feel like?
If you live in the United States, you learn what various temperatures feel like. You recognize that 86 degrees Fahrenheit is typical of a hot summer day and that -4 degrees Fahrenheit is a very cold winter day.
What is a kilowatt hour? Kilowatt hour.
Unit of energy used to measure electrical energy.
What is a center of gravity?
Depends on how weight of extended object is distributed. The object's motion is the same as that of a point object in which the gravitational force that acts on its center of gravity.
How does a person hear sound?
The ear is the organ used to detect sound in humans and some animals. The ear consists of three major sections: the outer ear, middle ear, and inner ear. The outer ear, the external section of the ear, consists of a cartilage flap called the pinna. The pinna's size and shape forms a transformer to match the impedance of the sound wave in air. To that at the end of the ear canal by gradually funneling the wave's sound energy into the ear. To hear more sound, people can increase the size of the pinna by cupping their hand around the back of the pinna, in effect, increasing its size and funneling capabilities. Once the sound has entered the ear canal, it moves toward the eardrum, where the longitudinal waves cause the eardrum to move in and out depending upon the frequency and amplitude of the wave. The middle ear includes the eardrum, the hammer, anvil, and stirrup, the three smallest bones in the human body, and the oval window on the inner ear. The eardrum is 17 times larger than the oval window, and this difference in area makes the inner ear act like a hydraulic machine, increasing the changes in pressure on the eardrum to that on the oval window at least 17-fold. The three bones link the eardrum to the oval window. They act like a lever system to further increase pressure on the oval window. The mechanical advantage of the lever system varies with frequency, peaking at about 5 in the 1 to 2 kHz frequency range. Thus the middle ear is like a complex machine that can amplify the pressure on the eardrum by a factor approaching 100 as it transfers the energy of the sound wave to the inner ear. Muscles connected to the eardrum and the three bones can react to very loud sounds and reduce the sensitivity of the ear, thus protecting it from damage. The inner ear is a series of tubes and passageways in the bony skull. It consists of the cochlea, a spiral-shaped tube that changes the longitudinal sound wave into an electrical signal on the nerves connecting the ear to the brain. The inner ear also has three semicircular canals that sense the body's motions and give rise to a sense of balance. The oval window is at one end of the cochlea. Sound waves transmitted through the middle ear to the oval window cause a traveling wave in the fluid of the cochlea. This wave in one of the three tubes within the cochlea, the organ of Corti, causes hair cells, called cilia, to tilt back and forth. The tilting causes chemicals to pass through channels in the nerve, creating electrical impulses that travel along the auditory nerve to the brain for analysis. The further the hair cells are from the oval window, the lower the sound frequency to which they are sensitive. Thus different nerves are excited by different frequencies, allowing the ear to distinguish the sound's frequencies.
How does gravity act on us? Is it a contact force?
Newton recognized that the gravitational force of Earth acts not only on objects close to Earth, like the famous apple, but also on objects as far away as the moon. But, how exactly does a celestial object such as the Sun reach out the approximately 93 million miles and hold Earth in its orbit? An early idea was that it was an action at a distance force, for example, that the Sun attracted all objects, like Earth, without anything between the two. In the middle of the 19th century, physicist Michael Faraday (1791 to 1867) proposed that one magnet creates a field of force around it, and another magnet interacts with the field at its location. Based on the field idea, Earth then creates a gravitational field. The apple and the moon have a force exerted on them, not directly by Earth, but by the gravitational field that exists at the location of the apple and the moon.
What is cosmology?
Study of the formation, properties, and future of the universe, galaxies, and stars.
What is a Pascal, Pa?
Unit of measure of pressure. 1 Pascal is 1 Newton per square meter.
What is a refractor telescope?
Uses one lens to gather, refract, and focus light toward an eyepiece that contains one or more lenses that create an image that the eye can see.
How do blimps remain at a chosen altitude?
A blimp is a non-rigid airship that floats in the air solely due to the buoyant gas within the giant balloon-like bag. It typically carries over 5,000 cubic meters of helium at a density about 7 times less than air. An airship floats in the air in the same manner as a ship floating in water. The weight of the airship must equal the buoyant force of the gas inside the bag. In order to increase the altitude of the blimp, the pilot increases its buoyancy by adding gas from pressurized tanks to the blimp, which expands the flotation bladders, displacing the heavier air and increasing the buoyant force until the reduced weight of the blimp equals the reduced weight of the air. To lower the airship, the buoyancy is decreased by releasing gas from the flotation bladders, which then decrease in size, displacing less of the heavier air. Because helium is a safer gas than hydrogen, it is what is used in today's blimps.
What is a direct current, DC?
Charges travel only in one direction.
What are the masses of the quarks and leptons?
Because quarks can't be separated, their masses can only be found by using one or more theories to calculate them. The masses of the charged leptons can be measured to high precision. In the Standard Model, neutrinos are all massless. But recent experimental results demand that they have mass. Masses are given in a unit that is energy divided by the speed of light squared, based on Einstein's E equals mc2.
What is an ampere, A?
Unit of measure of electric current. Equal to 1 coulomb of charge passing through a wire divided by 1 second.
What is a strong nuclear force?
Force within nucleus that acts between protons and protons. Protons and neutrons, and neutrons, and neutrons, all with the same strength.
What major discovery did Archimedes make in the 3rd century BCE, and how did he apply it?
Archimedes, c. 287 c. 212 BCE, lived in the city of Syracuse on the island of Sicily, then part of Greece. He was charged by the king of Sicily to find out if his crown was made out of pure gold, or an alloy of gold and silver. Archimedes had to do this without destroying the crown. One day, when bathing in the public baths, he noticed that when he stepped into the bath, the water rose. He had seen this many times before, but this time he recognized that this common occurrence could help him solve his problem. Legend has it that he was so excited that he ran naked through the streets of Syracuse, shouting "Eureka!" or "I have found the answer." He then did experiments where he hung the crown on one end of a balance and a piece of first gold and then silver from on the other end. When the weight of the crown and that of the metal were equal, the balance was horizontal. He then immersed the balance in water. If the crown and the metal had different volumes, the water they displaced would be different and the balance would tip. He found that the balance tipped when both the silver and gold pieces were on the balance. Archimedes had found that the crown was not pure gold, but a mixture of silver and gold. The king had been cheated. Archimedes had discovered a principle of hydrostatics, liquids at rest, that would one day carry his name. Archimedes' principle states that an object immersed in a fluid will experience a buoyant force equal to the weight of the displaced fluid. A huge steel ship like an aircraft carrier can float instead of sink like a stone, because it can displace enough water to compensate for its weight, and because the air inside of the ship makes its density actually less than the water around it.
What is Ohm's law?
In the early 1800s, George Simon Ohm, 1789 to 1854, a German physicist, developed the law that bears his name: the resistance of an object is independent of current through it. Many materials do not obey Ohm's law. For example, when the current through the tungsten filament wire in a lamp is increased, the temperature of the wire increases, and so does its resistance.
What is heat conduction?
Occurs when two objects are in contact, like when you put your hand in hot water.
What is a polarized wave?
Transverse wave, like light, with amplitude in one direction.
Why, then, are there 7 colors rather than 6?
It's because Isaac Newton was drawing an analogy between color and musical tones. There are 7 notes in the familiar European scale: A, B, C, D, E, F, and G. So, Newton decided there should be 7 colors in the spectrum, and he identified indigo as the 7th. So don't be too disappointed if you can't see it.
Why then, don't we see a violet sky?
Our eyes are most sensitive to colors in the midsection of the spectrum, about 550 nanometers. Because blue is closer to this wavelength, our eyes are more sensitive to it than indigo and violet.
Does my neighbor's motorcycle have to be that loud?
At times, engineers try to achieve just the right sound or noise for a particular product. The product, whether it's a vacuum cleaner, lawnmower, or motorcycle, needs to be quiet enough so as not to cause stress, yet has to have enough sound to seem powerful. For example, muffler technology has the ability to greatly reduce the noise a motorcycle produces. Yet many engineers and manufacturers feel that consumers would not purchase the product if it does not sound powerful enough.
How are clocks important to the development of gears?
As clocks have improved, so have the gears used within them. The pendulum clock uses a type of a gear called an escapement to drive the pendulum, which regulates the time marked out by the clock. Precision gears allow clocks to use less power and have greater accuracy.
What is diamagnetic?
Caused by circling electrons that create their own magnetic field. Material is repelled by magnetic fields.
What are elementary particles?
Study of the interactions and properties of the particles from which all matter is built.
What exerts this force?
If the cube is at the edge of the container, then the container exerts the force. You can check that for yourself. Use an empty fluid container, say a juice box or milk carton. Punch a hole in one side. Pour water into the container. To keep the water from leaving through the hole, you have to exert a force with your thumb. The same would be true if the hole were in the bottom.
What are other examples of impulse and change of momentum?
If you catch a baseball or softball, especially without a mitt, you know that you move your hand in the direction the ball is moving. You certainly don't move it toward the moving ball. In stopping the ball, its change in momentum is the same, no matter how you catch it. Thus the impulse your hand gives the ball is also the same. What changes? When you move your hand in the direction of the ball, you increase the time. The force of your hand acts on the ball. That means that the force is less.
How do convection currents create sea breezes?
During a day at the shore, the sun warms the ground and the water. The ground has a lower specific heat, and so its temperature increases more than the temperature of the water. The ground heats the air above it, which rises in convection currents, and cooler air from over the ocean flows toward the shore to fill in the gap left by the rising warm air. This flow of cooler air from the ocean toward the shore creates what is known as a sea breeze. In the evening, when the sun dips below the horizon, the ground cools faster than the water. Therefore the air over the ocean is warmer than the air over the shore, and the reverse takes place. The warmer ocean air rises while a breeze flows from the shore to the water.
Why does a stone sink but wood float?
A stone is more dense than water. That is, if you compare the mass of a stone to the mass of the same volume of water, the stone's mass will be greater. Therefore its weight will also be greater, so a stone weighter will be positive. And there will be a downward net force. Therefore the stone will move downward through the water until it rests on the bottom. Wood, on the other hand, is less dense than water. If the wood is pushed under water, water will be negative. There will be an upward force on the wood and it will rise.
What materials are attracted to magnets?
Iron, nickel, and cobalt, and most of their alloys are attracted to magnets. Other metals, like silver and gold, copper, tin, stainless steel, zinc, brass and bronze are not attracted. Nonmetals are not attracted. Iron, nickel, and cobalt are called ferromagnetic. All materials respond to magnetic fields, but most respond so weakly that the forces are hardly felt. Those that are repelled are called diamagnetic, those attracted are paramagnetic.
What is a lepton?
Lightweight particles like electrons and neutrinos.
What is gravitational field energy?
Energy stored in the gravitational field when an object moves away from the larger object that is attracting it.
What is a sustainable energy source?
Primarily wind, water, and solar energy, ultimately receive their energy from the sun, and therefore will be available for billions of years.
How does heat flow by conduction?
When part of a substance is heated, its thermal energy is increased. The fast-moving atoms or molecules strike the slower-moving cooler atoms. They begin to move faster, and so gain thermal energy. Their temperature increases. The ease of conduction depends on the material. Most metals are good conductors. Even a small difference in temperature produces heat flow. Other materials are poor conductors. There can be large temperature differences without significant heat flow. In that case, one part of the substance is hot, another cold. Heat conductivity is higher in metals that have freely moving electrons. So copper, silver, gold, and aluminum are good conductors. Stainless steel is a poor conductor. In nonmetals, conductivity depends on their ability to transfer vibrations of the atoms. The conductivity of ice, concrete, stone, glass, wood, and rubber is less than 1/100 that of metals. Conductivity depends on the material, its thickness, the area it covers, and temperature difference. Light gases have better conductivity than heavier gases. For example, the heavy gas argon is used to fill the space between dual pane windows because of its lower heat conductivity.
What is a wave?
A traveling disturbance that moves energy from one location to another without transferring matter.
What is a mirage?
Occurs when there is a temperature difference between the air directly above the surface, which is hot and thus less dense, and the cooler, denser, air a few meters above the surface.
What are total internal reflection and critical angle?
Total internal reflection occurs when a ray of light in a medium with a higher index of refraction strikes the interface between that medium and one with a lower index of refraction. When the incident rays are at a small angle with respect to the perpendicular to the interface, the rays pass through the interface being refracted to a larger angle. As the angle of incidence increases, so does the refracted angle. At the critical angle, the refracted angle is 90 degrees, that is, the ray's direction is along the interface. If the angle of incidence is increased any more, there is only a reflected ray. The refracted ray no longer exists. Because all the light is reflected, it is called total internal reflection.
What is brass?
An alloy that is typically 80% to 90% copper with zinc.
Does the amplitude of a wave depend on distance from the source?
The energy carried in a wave depends on the wave's amplitude and its velocity. Waves can be put into two categories: those that spread, like water waves on a pond, sound waves, or electromagnetic waves, and those that are confined to a narrow region, like waves on a rope or electrical oscillations on a wire. A water wave spreads on the surface of a pond, lake, wide river, or ocean. As it spreads, its energy is spread over a larger area. So the energy transmitted to a particular location is reduced when the source is farther away. Therefore, the amplitude of the water wave is also reduced in proportion to the distance from the source. Sound and electromagnetic waves usually spread in two dimensions. Again, as they spread, the energy carried is also spread, so as the distance from the source is increased, the amplitude is decreased, but this time as the square of the distance. On a rope or wire, the wave doesn't spread, but often a different mechanism reduces the amplitude. In a rope there is friction between the fibers, which changes some of its kinetic energy to thermal energy. If a signal is sent through a wire as an oscillating voltage, the resistance of the wire will convert some of the electric energy to thermal energy, reducing the voltage and thus the amplitude of the wave. This loss is reversed by putting amplifiers along the wire, putting more energy into the wave and increasing its amplitude.
What were uses of the Leyden jar?
In the late 18th and 19th centuries, people attempted to use the Leyden jar in a variety of ways. Some felt that it could cure medical ailments, and many doctors used the jar as primitive electroshock therapy. Others used it as a demonstration device and for entertainment purposes. Still more people felt that it could be used in cooking. Try cooking a turkey with an electrical spark.
What is a transformer?
Impedance matching device.
Why do some athletes go to high elevations to train?
Runners have always trekked to the mountains of Colorado to train in higher elevations because of the lower atmospheric pressure that the mountains provide. Since the air is not as dense as it is at lower elevations, the lungs need to work harder to supply the body with a sufficient amount of oxygen. Many athletes feel that training in such conditions gets their bodies used to lower amounts of oxygen. Therefore, when running in a competition at lower elevations, they can compete quite well because their bodies are used to working hard to get a great deal of oxygen.
How did resonance destroy the Tacoma Narrows Bridge in Washington state?
The Tacoma Narrows Bridge, or Galloping Gertie as it was often called, was built in 1940 and was known for its unusual, undulating movement. All bridges vibrate to some extent, but to many motorists, the suspension bridge in Tacoma felt more like an amusement park ride than a bridge. On the morning of November 7, 1940, 4 months after the bridge opened, the wind was blowing at approximately 42 miles per hour. This moderate wind hit the solid bridge deck and caused the deck to vibrate back and forth as it did almost every day since the bridge had opened. But the bridge began to vibrate more dramatically than ever before. It appeared as though a standing wave had formed between the two towers of the bridge. There was one distinct node in the center of the bridge and an antinode on each side of the node. After several hours of dramatic vibrations, the bridge deck collapsed into the river below. Along with its only casualty, a dog named Tubby, left in a car by its owner, who narrowly escaped death himself. there is still an active controversy about the exact cause of the collapse of the bridge.
What is electricity, resonance?
Produced when plastic, amber, or sealing wax is rubbed.
What was done to correct the Hubble's vision problems?
Three years after the Hubble was placed in orbit around Earth, a team of astronauts from the Space Shuttle Endeavour installed two tiny mirrors that would correct the focusing problems that the Hubble was experiencing. The telescope has since had several servicing calls, the most recent in 2009. Upgraded detectors and spectrometers have been installed. Faulty positioning gyroscopes replaced, and its batteries replaced. The batteries are used when Earth's shadow blocks the sunlight on the solar panels. Since its repairs, the Hubble Space Telescope has aided research into the age of the universe and the rate at which it is expanding, and has enabled observation of other stars and galaxies that previously were never seen by Earth-bound telescopes. More than 8,000 scientific papers have been published using Hubble data. Equally important, the beautiful photos taken by Hubble have fascinated the public and broadened its understanding of the incredible range of objects in our universe.
What is a precession?
The rotation of the axis of rotation of a rotating object due to a torque on the object.
What is an electric field?
As discussed before, a gravitational field surrounds Earth or any object with mass. Another object with mass that is placed in this field will experience a gravitational force on it. In the same manner, an electric field surrounds a charged object. Another charged object placed in that field will experience a force. If a positive force creates the field, then the force caused by the field on a negative force will be toward the source of the field. A positive charge will experience a force away from the source. The English physicist Michael Faraday, 1791 to 1867, was the first to use the concept of a field to describe the electrostatic force.
What is loudness?
Measure of how a listener responds to intensity of sound. Measured in sones.
What happens if the two forces are in opposite directions? What happens if both forces are equal? If one is stronger than the other?
If they are both equal, the car will remain motionless. That is, it will act as if there is no force on it. If one is stronger than the other, then it will move in the direction of the smaller force, but it will accelerate less. That is, the results will be the difference between the two forces. We'll explore forces that act in different directions later. Physicists say that the combination, addition, or subtraction of forces produces a net force, and it is the net force that affects the acceleration. Thus Newton's laws should be written as follows. Newton's first law: if there is no net force on an object, then if it was at rest it will remain at rest. If it was moving, it will continue to move at the same speed and in the same direction. Newton's second law: if a net force acts on an object, it will accelerate in the direction of the force. The acceleration will be directly proportional to the net force and inversely proportional to the mass. That is, A equals Fnit/m. Or, Fnit equals ma. Couch is heavier, the opposing force will be larger. The amount of force opposing you will depend on the surface the couch is on. A carpet will have a stronger opposing force than a smooth surface, like wood or tile. These observations summarize the properties of friction between two objects that are in contact. Friction is always in the direction opposite the motion. Friction is greater if the moving object is heavier. Friction is greater if the surface is rougher. But, friction does not increase if the speed of motion increases.
What is the difference between a dead load and a live load?
In order to remain static, bridges, and all structures, for that matter, must be able to withstand loads placed on them. A load is simply the engineering term for force. Dead load is the weight of the bridge or structure itself. The live load, on the other hand, is the weight and forces applied to the bridge. As a result of the vehicles and people that move across the bridge at any one time. Of course, in order to be safe, engineers account for much higher live loads than would normally occur.
Why do closed containers sometimes dent or even collapse on cool days?
Just as a balloon can become smaller when placed under water, a sealed container can change its shape and even collapse under certain atmospheric conditions. For example, a container that stores gasoline for a lawnmower is usually sealed when it's not being used. If the container were sealed on a warm day, when there was little atmospheric pressure, subsequently on a cool, high-pressure day, the gasoline container could be crushed. A second reason is that gasoline vapor exists in the tank. And at low temperatures more of the vapor condenses to liquid, reducing the pressure of the gases in the tank.
What is the second law of thermodynamics?
In the early 1800s, many scientists and engineers worked to improve the efficiency of steam engines. The French military engineer and physicist Sidi Carnot, 1796 to 1832, tried to answer two questions. Is there any limit to the amount of work available from a heat source? And can you increase the efficiency by replacing steam with another fluid or gas? Carnot wrote a book in 1824 called Reflections on the Motive Power of Fire that was aimed at a popular audience, using a minimum of mathematics. The most important part of the book was the presentation of an idealized engine. This engine could be used to understand the ideas that can be applied to all heat engines. A heat engine is a device that converts heat into work in a cyclical process. That is, the engine periodically returns to its starting point. A steam engine, gasoline, or diesel power automobile engine are all heat engines where the pistons return to their starting positions. A rocket is not a cyclic heat engine. A diagram of Carnot's simplified model allowed him to give answers to his two questions. He found that the efficiency, that is, the work output divided by the heat input, depended only on the temperatures at which heat enters and leaves the system, or efficiency equals, thought, cold/thought. It doesn't depend on the fluid or gas used in the engine. Real engines would have lower efficiencies, but no engine could have a higher efficiency. A simplified version of the second law according to Carnot is that it is impossible to convert heat completely into work in a cyclic heat engine. There is always some heat output. Note that the first law would allow a heat engine to have no heat output. The heat input would equal the work done. The second law can be shown in the diagram below, where the input heat is taken from a reservoir that maintains a constant high temperature and the output goes to a second reservoir at a constant low temperature. For example, a steam turbine gets its heat from high temperature steam and puts its output heat into a much colder lake or river. This turbine plant in California uses natural gas to heat water into steam that then produces energy in the turbines that generate electricity. Not all the energy from the natural gas can be converted to electricity, and lost energy escapes as heat. Carnot's model engine is reversible. That is, it can be run backwards, which is impossible for a real engine. Thus all real engines are less efficient than the ideal one. Friction also lowers the efficiency of real engines. The second law, according to Carnot, means that there is no such thing as a perpetual motion machine. Although such a machine could obey the law of conservation of energy, the heat it puts out means that the machine would eventually stop. Carnot died in a cholera epidemic at age 36. Because people were concerned with the transmission of this deadly disease. All his papers and books were buried with him after his death. Thus only a few of his works have survived. Despite the limitations of Carnot's model, his work inspired Rudolf Diesel, 1858 to 1913. To design the engine named after him to achieve higher efficiencies than steam engines. So, Carnot's book was important to the design of practical engines. A second version of the second law can be stated as heat doesn't flow from cold to hot without work input. For example, a refrigerator removes heat from the food at a low temperature and outputs heat from the coils in the bottom or back of the refrigerator. It will not move the heat from cold to hot, however, without a motor doing work on the circulating gas.
What does it mean to say that water seeks its own level?
The surface of water placed in a single container, a glass or a bathtub or a lake, will remain at the same level relative to Earth on both sides of the container. Adding water to one side will only make the entire level uniformly rise. There can never be one section of the glass or tub or lake that is at a higher elevation than another section. To understand this fact, consider adding the small cube of water on top of the surface at one location. It would exert a downward force on the water under it. But, because water can flow, water under it would flow outward, raising the level elsewhere in the container until the pressure is equal everywhere. Water also seeks its own level in other containers. If you fill a hose or tube with water and hold the tube in a U-shape, the water level will be at the same locations in the two ends. You can use the U-tube to make a device to show you equal heights at two different locations. You may have a coffee maker that has a water height indicator on the side. This is a small tube that connects to the water reservoir at the bottom. The water level in the narrow tube and the wide reservoir is the same.
What is the difference between a kilowatt and a kilowatt hour?
A kilowatt, 1000 watts, is the unit used to describe the power. The rate at which the energy is being converted. Energy is the power multiplied by the time it is used, in this case hours. Therefore a kilowatt hour, the product of power and time, is a unit of energy. The utility company charges you for the number of kilowatt hours of electricity you use in a month. For example, a 100-watt light bulb uses 100 watts, or 0.1 kilowatt, of power. If that light bulb were left on for an entire month, the energy that the bulb consumed would be 0.1 kilowatts x 24 hours/days x 30 days/month, which equals 72 kilowatt hours/month. If the energy cost is 12 cents per kilowatt hour, the bill for that one light bulb would be $8.64 per month. Replacing the 100-watt incandescent lamp with a 23-watt compact fluorescent lamp that is equally bright would cost only $1.98 per month. An LED lamp equally bright has a power rating of only 13 watts, and therefore would cost $1.12 to light.
How can resonance cause crystal glasses to break?
Many years ago, Ella Fitzgerald performed a physics experiment in an advertisement for Memorex, R. Audio tape cassettes. The company claimed that the famous singer could create a pure tone at just the right frequency to cause a crystal wine glass to break, and that the Memorex, R. tapes recorded and played back sounds so accurately that the glass would break both when Ms. Fitzgerald sang and when the recorded sound was played. Is it live or is it Memorex, R? was the advertising question. Although it is hard to think that glass is something that can bend. If you tap the rim of a thin wine glass, you can hear it ping. The shape of the rim of the glass oscillates. When the amplified sound waves pushed on the glass, it distorted its shape. Some of the kinetic energy in the sound wave was transferred into the kinetic energy of the oscillating glass. When the frequency of the sound wave matched the natural frequency of the glass, the amplitude of oscillation was large enough to shatter the glass. Sound can make glass break when amplified because the sound waves can cause the glass to oscillate and bend. When enough kinetic energy is used, the sound waves can distort the glass to the point where it cracks or shatters.
Can sound take the ocean's temperature?
Between 1995 and 1999, the ATOC, or Acoustical Thermometry of Ocean Climate, experiments measured the speed of sound in the Pacific Ocean. Sound sources at 75 Hz were located off the California coast and near the island of Kauai in Hawaii. Detectors were positioned at various depths off the coast of Alaska, near the Big Island of Hawaii, near Kamchatka, Russia, and New Zealand. The speed of sound compared to the speed of light can be observed at a baseball game. A spectator sitting in the outfield bleachers sees the batter hit a ball before she hears the crack of the bat.
What is biophysics?
Study of the physical interactions of biological molecules.
Are there antiquarks like there are antineutrinos and antielectrons, positrons?
Yes, there are anti-up quarks with charge -2/3 and anti-down quarks with charge 1/3. An antiproton is composed of 2 anti-up and 1 anti-down quarks. Antiquarks have color charges that are the complementary colors to red, green, and blue: cyan, anti-red; magenta, anti-green; and yellow, anti-blue. An up, or down, quark and an anti-up, or anti-down quark will annihilate each other, resulting in energy being released.
What is physics?
Physics is the study of the structure of the natural world. It seeks to explain natural phenomena in terms of a comprehensive theoretical structure in mathematical form. Physics depends on accurate instrumentation, precise measurements, and the expression of results in mathematical terms. It describes and explains the motion of objects that are subject to forces. Physics forms the basis of chemistry, biology, geology, and astronomy. Although these sciences involve the study of systems much more complex than those that physicists study, the fundamental aspects are all based on physics. Physics is also applied to engineering and technology. Therefore, a knowledge of physics is vital in today's technical world. For these reasons, physics is often called the fundamental science.
What is a VAD de Graaff generator?
Device using static electricity to produce very large potential differences.
What is a dip needle and how is it similar to a compass?
A dip needle is just like a conventional compass. But instead of holding it horizontally, it is held vertically. It is a magnetic needle used for navigational purposes just like a compass, but is used predominantly when traveling around the North and South poles. Instead of measuring horizontal magnetic deflection, the dip needle measures vertical magnetic inclination. When over the equator, the magnetic field of Earth is parallel to the surface of the Earth. The closer one gets to the magnetic poles, however, the less pilots rely on compasses, and the more they rely on dip needles to tell them how close they are to the poles. The closer one gets to a pole, the more vertical the magnetic field becomes, because it's turning into the surface of Earth. Therefore, when directly over the magnetic poles, the dip needle points directly downward.
What is white noise?
Roughly equal sound intensities at all frequencies.
What is the third law of thermodynamics?
Absolute zero can never be reached.
What is the Global Positioning System, GPS?
Consists of 24 satellites in 12-hour orbits that broadcast their location and the time the signal was sent. A control system that keeps the satellites in their correct orbits. sends correction signals for their clocks as well as updates to their navigation systems, and a receiver.
Has Einstein's theory been tested?
It has been tested in many ways. It is being used every day in adjusting the clocks in GPS satellites. They run faster because they are at high altitudes where the distortion of space-time is smaller. Both the effects of special relativity, clocks running slower, and general relativity. Clocks running faster must be used to keep the clocks running accurately.
What is a sonic boom?
A sonic boom occurs when an object travels faster than the speed of sound. The boom itself is caused by an object, such as a supersonic airplane, traveling faster than the sound waves themselves can travel. The sound waves pile up on one another, creating a shock wave that travels through the atmosphere, resulting in a boom when it strikes a person's ears. A sonic boom is not a momentary event that occurs as the plane breaks the sound barrier. Rather, it is a continuous sound caused by a plane as it travels at such a speed. But the shock wave travels with the plane, so we hear it only when the plane is in one location. Supersonic planes, such as this F-15 fighter jet, can go beyond Mach 1. When they do, they generate a sonic boom caused by sound waves piling up and creating a shock wave. All objects that exceed the speed of sound create sonic booms. For example, missiles and bullets, which travel faster than the sound barrier, produce sonic booms as they move through the atmosphere. The shock wave created by an F-15 fighter plane, for instance, is visible.
If the low-wavelength light is scattered, why do we only see a blue sky and not a blue, indigo, and violet sky?
Lord Rayleigh, John Strutt, 1842–1919, determined that the nitrogen and oxygen molecules in the atmosphere scattered sunlight, allowing us to see the sky. The scattering is strongest at the lowest wavelengths.
What's the strength of gravitational fields of other astronomical objects?
This table shows the properties of the Sun, planets, and Earth's moon. It also shows the strength of the Sun's gravitational field at each planet, and the strength of the planets' gravitational fields at their surfaces. The Sun and Jupiter, Saturn, Uranus, and Neptune are gaseous and have no solid surfaces.
What are simple machines?
Simple machines are devices that match human capabilities to do work to tasks that need to be done. They can reduce the force required or reduce the distance or direction an object must be moved. Because we will eventually run out of fossil fuels, we need to explore other, more sustainable forms of energy, such as solar power. Suppose you want to lift a heavy object. If you use a machine, you will use your stored chemical energy to do work on the machine. The machine, in turn, does work on the object, which increases its energy. If the force is constant and in the direction of motion, then work is the product of force and distance moved, W equals Fd. The mechanical advantage, ma, of a simple machine is the output force divided by the input force, Foutput/Finput equals ma. To make the output force larger than the input force, you must choose a machine that has a mechanical advantage larger than 1. The drawing below illustrates the process. Note that you exert a small input force over a large distance. The machine exerts a larger output force over a smaller distance.
Why would you need to know the time this accurately?
Businesses that use computers in many parts of the world can synchronize their computers so that the precise time that transactions occurred are known. GPS also provides navigation information. Hikers use GPS to replace maps, which are often outdated, compasses, and lists of landmarks. Automobile and truck drivers use GPS to replace paper maps and to find local businesses, such as banks, restaurants, and gas stations. Farmers use GPS to map precise locations in their fields. Not only does this information improve planting, it can be used to mark the locations of areas that need additional insect control chemicals or fertilizers. Engineers are now working on GPS systems to improve the flow of automobile traffic and reduce crashes. Each car would have a GPS receiver that would then broadcast its position. This information could be used to change red traffic lights to green if there were no opposing traffic. If two cars were equipped this way, the system could determine the distance between them and their relative speeds. If they were on a collision course, the system would apply the brakes to avoid a crash.